Hello everyone, welcome to Wings of Physics. Myself, Deepali Kulkarni from PVP Junior College, Pravaranagar, लोणी. 12वीच्या प्रिय विद्यार्थी मित्रांनो, तुमची वार्षिक परीक्षा खूप जवळ आलेली आहे. काहींची सराव परीक्षा ही चालू आहे, काहींची सुरू होणार आहे. आणि आपल्याला खूप मोठा प्रश्न पडलाय की इतका मोठा सिलेबस आणि तो आता कव्हर कसा करायचा. वर्षभर काहींनी सिन्सिअरली अभ्यास केला असेल, काहींनी टंगळमंगळ केली असेल आणि आता अभ्यास करणाऱ्यांना पण, वर्षभर अभ्यास करणाऱ्यांना पण आणि न करणाऱ्यांना पण बरंचसं टेन्शन आलेलं आहे. आणि त्याच्यामुळे तुम्हाला काहीतरी मार्ग दाखवावा, कमी कालावधीमध्ये अभ्यास कसा करावा याचं मार्गदर्शन व्हावं या हेतूने तुमचा मनावरचा ताण कमी करावा आणि सिलेबस कमी वेळेत कसा सिलेबस आता अभ्यासावा याच्यासाठी मी आजपासून माझी वन शॉट लेक्चरची 12वी करताची सिरीज सुरू करत आहे. आणि त्यातला पहिला चॅप्टर आहे थर्मोडायनॅमिक्स. कदाचित या वन शॉट सिरीजमध्ये जे जे मोठे चॅप्टर आहे त्यांचे 2 भाग होतील, 3 भाग होतील. पण एक चॅप्टर जर अभ्यास करायचा तर तुम्हाला एक दिवस तर सहज लागणार आरामशीर. आणि त्याऐवजी तुम्ही जर 2 तास फक्त व्हिडिओ बघितला तर तुमची बरीचशी तयारी होऊन जाईल. आणि म्हणून मी असं ठरवलंय की आपण त्याचे वन शॉट लेक्चर करूयात. आणि म्हणूनच चला तर मग वेळ न घालवता सुरुवात करूया आपण या सिरीजला. पहिला चॅप्टर अर्थातच थर्मोडायनॅमिक्स आणि त्याचं वन शॉट पार्ट फर्स्ट. ओके, नाउ व्हॉट इज द मीनिंग ऑफ थर्मोडायनॅमिक्स. काय आहे थर्मोडायनॅमिक्स या शब्दाचा अर्थ. थर्म म्हणजे हीट आणि डायनॅमिक्स म्हणजे when we supply heat to any object or any system, at that time that gets converted into the work, or it may be converted into internal energy or vice versa. Understood? म्हणजे आपण जेव्हा एखाद्या सिस्टीमला, सपोज दिस इज अ सिस्टीम and we supply heat to that system, at that time work is done. Suppose this piston move upward direction, at that time work is done and the heat absorbed by that system, that is act as a change in internal energy, and that is called as thermodynamics. Therm means heat, and when heat is in motion, at that time it gets converted into the work or internal energy, or vice versa means internal energy it may be converted into the work, vice versa process is there, and that is called as thermodynamics. Now we have to study the concept of a thermal equilibrium. What is the concept of thermal equilibrium? Thermal equilibrium, for that purpose consider a 3 systems. System A, System B, this is System A, and System B. Then in between these 2 systems, a adiabatic wall is there. This is adiabatic wall. Adiabatic wall, and this wall, that is diathermic wall. Diathermic wall. Diathermic wall. What is the meaning of adiabatic wall? That is a thick wall, and due to that thick wall there is a no exchange of heat in between these 2 systems. And dithermic wall, this is system C, and these 2 systems and system C, they are separated by dithermic wall. Dithermic wall, that is a thin wall, and with the help of this thin wall this system can exchange heat with this system, and also this system is also exchange heat with that system. Understood? And when system A and system B, they are in thermal equilibrium. Thermal equilibrium, what is the meaning of thermal equilibrium? When 2 objects or when 2 systems, they are at same temperature, at that time we can say that they are in thermal equilibrium with each other. And therefore, suppose the temperature of this system A is 40 degrees Celsius and B is also 40 degrees Celsius, we can say that system A and B, these two are in thermal equilibrium. Suppose this is system A, system B and system C. And system, this double arrow indicates that these two systems, they are in thermal equilibrium with each other. And means temperature of system A and temperature of system B is same. This is figure A. Now, consider these two systems, system A and system C. Then double arrow is in between these two systems, means system A and C. Though they exchange heat due to diathermic wall, they are at same temperature. Means system A and C is in thermal equilibrium. And now what happen? If system A and B is in thermal equilibrium, system A and C is in thermal equilibrium, means this is having temperature C, then we can say that system B and C, that is also in thermal equilibrium. And therefore, the system B and system C, they are now this double arrow in between these two systems, that indicates that these two systems, they are in thermal equilibrium with each other. And that is zeroth law of thermodynamics. What is the statement of zeroth law of thermodynamics? If two systems are each in thermal equilibrium with third system. I repeat, if two systems are each in thermal equilibrium with third system, then they are thermal equilibrium with each other. बघा, या दोन सिस्टीम जर एकमेकाच्या थर्मल इक्विलिब्रियम मध्ये असतील, ह्या दोन सिस्टीम एकमेकाच्या थर्मल इक्विलिब्रियम मध्ये असतील, तर ह्या दोन सिस्टीम सुद्धा एकमेकाच्या thermal equilibrium मध्ये असतील. And that is the statement of zeroth law of thermodynamics. Now this zeroth law is used in thermometry. What is thermometry? Thermometry Thermometry. It is a branch of science which deals with the study of thermometer, okay, or which measures the temperature with thermometer, and that is called thermometry. And what is the use of thermometry? With the help of thermometer, we can explain the concept of thermal equilibrium, and there are the three scales, and we will study that three scales in thermal properties of matter, okay. Celsius scale, Fahrenheit scale, then the absolute scale, that is also called as Kelvin scale. All these different scales, they are arises in the thermometry, okay. Now we have to study about the system, surrounding and boundary. What is system? What is surrounding? What is the definition of system? What is the surrounding? And what is the boundary? Now consider, this is a gas that is enclosed in a cylinder. This is a gas, ideal gas, that is enclosed in a cylinder. Then that cylinder is fitted with movable, massless and frictionless piston. Always keep in mind that. What type of piston is there? That is movable, means that can easily move. Massless means that is light in weight, and frictionless, no friction is there. Why this condition is there? Due to that there is a no loss of energy, means we supply heat, and that heat, due to that the movable, massless and frictionless piston, there is a no loss of energy, and this ideal gas is there, and that is form a system. Then what is the definition of system? This is a system. What is definition of system? System, that is a group of object and that form a unit. Okay, the system is defined as a object that can form a unit and which may have a ability to exchange the energy with the surrounding. Understood? Means a group of object, this is a group of object that form a unit and that group of object that have a ability to exchange energy. This system can exchange energy with the surrounding. This is surrounding, or it is also called as environment. Environment. Okay. Then what is the definition of system? System, that is a collection or group of objects which may form a unit and that have ability to exchange energy with the surrounding. Understood? What is the definition of system? System is defined as a collection. It is a collection or group of objects and that have a ability to exchange energy with the surrounding or environment, and that is called as a system. बघा, तुमचा हा क्लास आहे आणि ह्या क्लासमधले जे काही तुम्ही स्टुडंट आहे, सपोज दिस इज 12th सायन्स क्लास, दिस इज 12th सायन्स क्लास and this is a collection or group of objects. All these students, those who are having class 12th science, they are a collection or group of objects. आणि तुमचा मित्र जर बाहेरून तुमच्याशी बोलत असेल, बघा या पद्धतीने तो तुमच्याशी जर बोलत असेल तर तुम्ही त्याच्याशी साऊंड एनर्जी एक्सचेंज करता, बरोबर की नाही? मग हा बाहेर आहे आणि तुम्ही सगळ्यांनी मिळून हे कलेक्शन ग्रुप ऑफ ऑब्जेक्ट तुम्ही मिळून कोणतं युनिट तयार केलं? 12th सायन्स क्लासचं युनिट तयार केलं आणि तुमच्याकडे ॲबिलिटी आहे की तुम्ही या बाहेर जो आहे म्हणजे जो सराउंडिंगमध्ये स्टुडंट आहे त्याच्याशी साऊंड आहे, आतून तुम्ही वर्गातून बोलू शकता त्याच्याशी, म्हणजे तुम्ही साऊंड एनर्जी काय करू शकता? एक्सचेंज करू शकता. तशी आपली ही सिस्टीम ह्या सराउंडिंगशी कोणती एनर्जी शेअर करते? तर ती हीट एनर्जी शेअर करते. Understood? And therefore, I repeat the definition. A system that is a collection or group of objects and that have a ability to exchange energy with the surrounding, that is called as a system. And what is the definition of surrounding or environment? Anything which is not a part of system. बघा, असा भाग की जो सिस्टीमचा भाग नाही, म्हणजे एवढा भाग सोडून राहिलेलं सगळं हे काय आहे? सराउंडिंग आहे किंवा एन्व्हायरमेंट आहे. मीन्स एनिथिंग दॅट इज नॉट ए पार्ट ऑफ सिस्टीम, दॅट इज कॉल्ड ॲज सराउंडिंग ऑर एन्व्हायरमेंट. आणि ह्या दोन्हींना सेपरेट जे करतं, बघा, दी वॉल ऑफ कंटेनर दॅट इज कॉल्ड ॲज बाउंड्री. A boundary separates system and surrounding from each other. या दोघांना वेगळं करणारं जो कोणी आहे, now this is the wall of container, that is the boundary. समजतंय? Okay, now we have to study the different types of systems. Different types of system. First is open system. First type, that is open system. Open system. Second type, closed system. Closed system. And third type, isolated system. Isolated system. Now, this is the figure for open system. This is heat, this is matter. Then figure for closed system. only heat is there. And this is the figure for isolated system. Okay. Now, a open system, a system which exchange heat and matter with the surrounding, that system is called as open system. आता बघा, मॅटर म्हणजे काय तर वाफ. बघा, सॉलिड, लिक्विड and gas, these are the three states of matter, and therefore a system which exchange heat and matter with the surrounding, then that system is called as open system. Now, closed system, a system which can exchange only heat, not matter, with the surrounding, that system is called as closed system. And isolated system, बघा इथं कुठलाच ॲरो नाही, मीन्स इट कॅनॉट एक्सचेंज हीट और मॅटर विथ द सराउंडिंग, दॅट सिस्टीम इज कॉल्ड ॲज आयसोलेटेड सिस्टीम. ओके. मग आता बघा, मला समजा आता मी लेक्चर घेते आहे आणि एका ग्लासमध्ये मला चहा आणून दिला, माझ्या मुलीने चहा आणून दिला, टी इज हिअर. आता मी तो चहा घेतला नाही, मग आता ह्या चहाच्या बाहेर आपल्याला त्या कपाजवळ आपण हात नेला तर आपल्याला उष्णता, हीट जाणवेल आणि त्यातून अशा वाफा पण बाहेर जाणार आहे. म्हणजे इथून हीट आणि ही वाफ म्हणजे मॅटर, हे दोन्ही सराउंडिंगशी काय झालं, एक्सचेंज झालं. आता मी हा चहा घेत नाही असं पाहिल्यानंतर माझ्या मुलीने त्याच्यावर झाकण आणून ठेवलं. मग आता बघा, त्या कपाच्या बाहेर आपण हात नेला तर आपल्याला फक्त हीट जाणवेल आणि मॅटर जाणवणार नाही. म्हणजे इथून फक्त हीट जाईल सराउंडिंगला, वाफ जाणार नाही, म्हणजे मॅटर जाणार नाही. आणि मी तरीही चहा घेत नाही असं पाहिल्यावर माझ्या मुलीने हा चहा थर्मासमध्ये ओतला आणि या थर्मास फ्लास्कमध्ये ओतल्यानंतर दोन्हीही बाहेर गेलं नाही, हीटही नाही आणि मॅटरही नाही. मग बघा, जेव्हा हा चहाचा कप ओपन होता की ज्याच्यातून हीट आणि मॅटर दोन्ही बाहेर जात होतं, ती कोणती सिस्टीम होती, ओपन सिस्टीम. जेव्हा त्याच्यावर झाकण ठेवलं या पद्धतीने तर फक्त हीट बाहेर गेली, वाफ बाहेर गेली नाही, म्हणजे मॅटर गेलं नाही, मग ती काय झाली, क्लोज सिस्टीम. आणि जेव्हा थर्मास फ्लास्कमध्ये तो चहा ओतला त्यावेळेस हीटही बाहेर गेली नाही आणि मॅटरही बाहेर गेलं नाही, आणि म्हणून त्यावेळेस त्या सिस्टीमला काय म्हणायचं, आयसोलेटेड सिस्टीम. इन युअर बुक द एक्झाम्पल्स गिवन आर वॉटर बॉइलिंग इन अ केटल. किटली असते बघा, त्याला बाहेर वाफ बाहेर जायला एक जागा असते, ओपनिंग असतं. म्हणजे जेव्हा किटलीमध्ये आपण पाणी तापवतो त्यावेळेस दोन्हीही बाहेर जातं, हीटही बाहेर जाते, वाफही बाहेर जाते, मॅटरही बाहेर जातं. म्हणून किटलीत उकळलेलं पाणी हे कशाचं उदाहरण आहे, ओपन सिस्टीमचं. क्लोज सिस्टीम, जेव्हा बॉयलरमध्ये आपण पाणी उकळवतो, पाणी तापवतो तर फक्त हीट बाहेर येते, मॅटर बाहेर येत नाही. आणि थर्मास फ्लास्कमध्ये आपण एखादं गरम लिक्विड घालतो तर दोन्हीही बाहेर जात नाही, हीटही नाही, मॅटरही नाही. त्या सिस्टीमला कोणती सिस्टीम म्हणायचं, आयसोलेटेड सिस्टीम. आय होप ऑल ऑफ यू अंडरस्टूड दिस कन्सेप्ट ऑफ ओपन सिस्टीम, क्लोज सिस्टीम अँड आयसोलेटेड सिस्टीम व्हेरी वेल. ओके. नाउ we have to study about the thermodynamic state variables. 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 State variables. Again consider a thermodynamic system and that is fitted with, again this is a system, and that system that is fitted with movable, massless and frictionless piston. Now the state of this system, that is expressed with the help of some variables. Macroscopic variable. What is the difference between microscopic and macroscopic? जे साध्या डोळ्यांनी आपण पाहू शकत नाही त्या व्हेरिएबल्सला म्हणायचं मायक्रोस्कोपिक. केटीजी अँड रेडिएशनमध्ये जे कोणते व्हेरिएबल्स आहेत ते मायक्रोस्कोपिक व्हेरिएबल्स आहेत आणि थर्मोडायनॅमिक्समध्ये म्हणजे प्रेशर, व्हॉल्यूम, टेम्परेचर, मास, all these are macroscopic variables and they describe, with the help of these variables we describe the state of a system. बघा या सिस्टीमची जे काही स्टेटस आहे त्याची स्टेट आहे ती आपण ह्या व्हेरिएबलच्या साहाय्याने एक्सप्रेस करू शकतो आणि म्हणून त्या व्हेरिएबल्सला म्हणायचं थर्मोडायनॅमिक स्टेट व्हेरिएबल्स. दे आर ऑल्सो कॉल्ड ॲज थर्मोडायनॅमिक स्टेट पॅरामीटर्स. अंडरस्टूड? अँड now these variables, they are divided into two groups, extensive and intensive variable. Now we have to study about the extensive and intensive variable. Extensive variable and intensive variable. Extensive variable and intensive variable. And intensive variable. Here I will give you one shortcut. Here n word is present and this n indicates that not. How to keep in mind? Intensive n is there and therefore n indicates that not. Then what is the meaning of this not? Now consider a glass of water and consider a bucket in which water is there. Now mass which is present in this glass and mass of water which is present in this bucket, that is different. This mass is smaller and this mass of water, that is smaller mass, and this mass of water which is present in bucket, that is larger. Means mass, that variable, this variable, that variable that depends on the size of system. If size is small, mass is small. Size is large, mass is large, and that variable is called as a extensive variable. Extensive variable is that variable which do not depend on the size of system. जे साईजच्या सिस्टीमवर which depends on the size of system. असं व्हेरिएबल की जे सिस्टीमच्या साईजवर डिपेंड आहे त्या व्हेरिएबलला कोणतं व्हेरिएबल म्हणायचं? एक्सटेन्सिव्ह व्हेरिएबल. मग आता बघा याचं मास वेगवेगळं आहे, साईजवर डिपेंड आहे. व्हॉल्यूम हे सुद्धा साईजवर डिपेंड आहे. आता बघा इथे जो व्हेरिएबल आहे इंटेन्सिव्ह व्हेरिएबल. इंटेन्सिव्ह व्हेरिएबल, ए व्हेरिएबल, सपोज अगेन कन्सिडर this glass of water and a bucket of water. Now density of this water and density of this water, that is 1 gram per centimeter cube in CGS system. This is the density of water. Though that water, size of that water, that is small or large, its density remains constant. And therefore density is that variable which do not depend on the size of system. This n indicates that not depend on a size of system, and that variable is called as intensive variable. Understood? A variable which depends on the size of system, that variable is called as extensive variable. And intensive variable, a variable which do not depend on the size of system, that variable is called as a intensive variable. Understood? Then pressure, temperature, density, all these variables, they are the intensive variable. And mass, volume and internal energy. Internal energy. When we compressed the gas, at that time internal energy increases or when we expand the gas, at that time internal energy decreases. Means internal energy, that variable also depends on the size of system, and therefore that variable is the extensive variable. Understood? And in this manner we distinguish between extensive variable and intensive variable. Suppose क्वेश्चन आला एक्सप्लेन एक्सटेन्सिव्ह व्हेरिएबल, तर फक्त इकडचा पार्ट लिहायचा, किंवा एक्सप्लेन व्हॉट डू यू मीन बाय इंटेन्सिव्ह व्हेरिएबल, तर इकडचा पार्ट लिहायचा. आणि जर डिफरन्स आला तर कोणतेही दोन फरक लिहायचे. तर या पद्धतीने आपण एक्सटेन्सिव्ह व्हेरिएबल आणि इंटेन्सिव्ह व्हेरिएबल या दोन्हींना एक्सप्लेन करू शकतो. समजलं का? आता पुढचं आपल्याला शिकायचे बघा. पुढची कन्सेप्ट आहे थर्मोडायनॅमिक इक्विलिब्रियम. थर्मोडायनॅमिक इक्विलिब्रियम. थर्मोडायनॅमिक इक्विलिब्रियम. Now study this concept. We have to consider a mechanical equilibrium. A mechanical equilibrium. Then we have to study chemical equilibrium. Chemical equilibrium. And third one, we have to study the thermal equilibrium. Thermal equilibrium. Then, what is mechanical equilibrium? System and surrounding. F that is equal to 0. Shortcut. How to remember mechanical equilibrium? F means force. When there is a no force acting in between system or in between system and surrounding, at that time we can say that system is in mechanical equilibrium. And again we know that pressure that is equal to force per unit area. If no force, then or constant force, at that time force per unit area is area of this system, that also constant, and therefore pressure is constant. Means there is a no unbalanced force acting in between system and surrounding, or pressure of the system that remains constant, that remains same. At that time we can say that system is in mechanical equilibrium. Now chemical equilibrium. Now consider this system, and in this system no chemical reaction. No chemical reaction. No chemical reaction. Or there is a no transfer of mass due to diffusion. Okay? No transfer of mass due to diffusion. And chemical no transfer of mass. No transfer of mass due to diffusion. Mass due to diffusion. And third one, chemical composition. Chemical composition of the system. Chemical composition of the system remains constant throughout. Remains constant throughout. Remains constant throughout. At that time we can say that system is in chemical equilibrium. 3 शब्द लक्षात ठेवा. No chemical reaction, no transfer of mass due to diffusion, and chemical composition of the system remains constant throughout the system. At that time we can say that system is in chemical equilibrium. And just now we studied that thermal equilibrium. If the temperature of system and surrounding that is same or constant, or it does not change with time, at that time we can say that system is in thermal equilibrium. And when systems simultaneously follow these 3 equilibrium, at that time we can say that system is in thermodynamic equilibrium. म्हणजे जर 1 मार्काला प्रश्न आला एक्सप्लेन मेकॅनिकल इक्विलिब्रियम और व्हॉट डू यू मीन बाय केमिकल इक्विलिब्रियम, एक्सप्लेन थर्मल इक्विलिब्रियम, तर सेपरेट लिहायचं. आणि 3 मार्काला जर प्रश्न आला की व्हॉट डू यू मीन बाय थर्मोडायनॅमिक इक्विलिब्रियम, ॲट दॅट टाइम यू हॅव टू एक्सप्लेन दिस 3 पॉइंट सायमल्टेनियसली. Understood? In this manner we can explain the thermodynamic equilibrium. Now we have to study the concept heat, work and internal energy in detailed manner. Let me clean the board first. Heat, work and internal energy. Internal energy. Internal energy. Internal energy. Now, if two objects, suppose a water is here, that water is having 30 degrees Celsius temperature and a hot sphere or bob that is at 90 degrees Celsius temperature, that is dropped into that cold water. This water is cold water and hot bob that is or sphere that is dropped into that liquid. Then what happened? The heat transfer from this bob to this water, this hot bob to this cold water up till the temperature of this mixture that becomes uniform. And that something transfer from this hot object to cold object, or the energy transfer from this hot object to cold object, and that energy that is called as a heat energy. Okay, means heat is energy transit that when two objects they are at different temperature and they comes contact with each other, at that time that energy flows from higher temperature to lower temperature. Now it is a scalar quantity. It is a scalar quantity. Then it is a path dependent term. It is path dependent term. Path dependent. Then its SI unit is joule and CGS unit is erg and another unit that is calorie. Calorie. What is the relation between joule and calorie? Then 1 calorie that is equal to 4.186 joule, that is nothing but 4.2 joule. Okay. Then what is the definition of 1 calorie heat? When a 1 gram of water, this is 1 gram water, and we have to increase its temperature from 14.5 degrees Celsius to 15.5 degrees Celsius. At that time we have to supply heat, and that heat that is nothing but 1 calorie heat. Means what is the definition or what is the meaning of 1 calorie heat? If we have to increase the temperature of 1 gram water from 40.5 degrees Celsius to 15.5 degrees Celsius, at that time heat supplied that is nothing but the 1 calorie heat, and that is the meaning of 1 calorie heat. Now heat absorbed by the system. When we supply heat to that system, heat absorbed by the system, that is always considered as positive, and heat lost by the system, that is always considered as negative. Understood? And consider these three figures. Suppose this is a system and this is the surrounding. Again, this is a system and this is the surrounding. Again, this is a system and this is the surrounding or environment. Then, the temperature of this system, Ts, and temperature of the environment, Te. Ts, that is temperature of system, and Te, that is temperature of environment or surrounding. When Ts is less than Te. Now just now we studied that heat always flows from higher temperature to lower temperature. Now heat is travel from the surrounding to environment, and at that time heat is absorbed by the system, and in this case the Q, that is heat, that is greater than 0 or it is positive. Understood? Now second case, when Ts is greater than Te, means temperature of this system that is greater, at that time heat flows from higher temperature to lower temperature, and therefore heat flows from system to environment or surrounding. Heat is lost by the system, and therefore the Q is less than 0 or negative. Understood? And when Ts that is equal to Te, and therefore there is no exchange of heat, and therefore Q that is equal to 0. Understood? In this manner, we can explain that heat absorbed by the system that is considered as a positive, heat lost by the system that is considered as negative, and when temperature of system and temperature of surrounding or environment is same, then Q that is equal to no exchange of heat, means Q that is equal to 0. In this manner, we can explain the concept of heat in detail. I hope all of you understood this concept very well. Then next concept, that is work. Again, work. Suppose this is a system. Again, that is fitted with movable massless piston, and when we supply heat, and due to that heat the expansion is there, means the piston move upward in this direction, and at that time work is done. Understood? And this work, when expansion is there, at that time, that is called work done by the system. Work done by the system. And this work that is always considered as positive. And when we compression is there, means piston moves downward in this direction. This is the original position, and piston moves downward in this manner, means a compression is there. In this case, expansion is there. And when heat is removed from the system, understood, at that time, means the Ts is greater than Te, at that time heat is lost by the system, and due to that a compression is there, and compression of gas is there, and at that time we can say that work done on the system, and at that time this work is considered as negative, and this is the sign convention used while calculating the work done. Then again, work done, that is a scalar quantity. Heat is a heat is a form of energy, and again the unit used to calculate the work, that is joule, calorie, and this is the interconversion. And again a most important term, that is work is a path dependent function. This function is path dependent. Work is path dependent. Path dependent. Understood? And in this manner we can explain the concept of work. Okay. Now we have to study about third variable, that is internal energy. Now for that purpose, consider this is ideal gas and this is real gas. This is real gas. Now in case of an ideal gas, in case of an ideal gas, there is no intermolecular force in between the gas molecules, and due to that, potential energy of this ideal gas that is equal to 0. Means total energy that is only due to the kinetic energy. Understood? And therefore, the internal energy, that is nothing but the kinetic energy, internal energy of gas, ideal gas, due to only the kinetic energy. But in case of a real gas, in between the gas molecule, there is an intermolecular force of attraction, and therefore real gas having kinetic energy plus potential energy. This is the difference between ideal gas and real gas. In ideal gas, the potential energy is absent, and therefore what is the definition of internal energy? Internal energy is the energy associated with random disordered motion of a molecules. Means internal energy that is nothing but the only kinetic energy, and therefore they are the molecules of the gas molecules. They are constantly moving in all possible direction with all possible velocities according to the kinetic theory of gas, and therefore the internal energy that is defined as the energy associated with random disordered motion of a gas molecule, that is internal energy. And always keep in mind that internal energy depends on a temperature. Internal energy depends on temperature. Depends on temperature only. Temperature only. Now this is the state function. These two are heat and work. They are path function. This is path function. This is also path function. But internal energy, that is a state function. Means it depends on initial state and final state of a system, and therefore it is a path function. Okay. And the formula to calculate the change in internal energy delta U, that is nothing but NCV dt. N, that is number of mole, CV, specific heat of a gas at constant volume, and dt, that is rise in temperature. And therefore this dt, internal energy, depends on temperature, and this is the formula. Later on we have to use this formula frequently in this chapter, and always keep in mind that delta U, that is change in internal energy, that is equal to NCV dt. Now we can change the internal energy of a system by two different ways. First, by supplying heat to the system. बघा, सिस्टीमला हीट दिली की तिचं टेम्परेचर वाढतं आणि इंटरनल एनर्जी सुद्धा काय होते, वाढते. आणि सिस्टीममधून हीट काढून घेतली तर तिचं टेम्परेचर कमी होतं आणि इंटरनल एनर्जी सुद्धा कमी होते. मीन्स इंटरनल एनर्जी कॅन चेंज बाय सप्लाइंग. फर्स्ट वे टू चेंज द इंटरनल एनर्जी इज दॅट बाय सप्लाइंग हीट टू द सिस्टम. And second way, if we compressed that gas, when we compress the gas, work done on the gas and its temperature that gets increased, and at that time the internal energy also increased. Always keep in mind that when compression is there, work done is negative and internal energy is positive. When compression is there, temperature of system goes on increasing and internal energy also goes on increasing because internal energy depends on temperature only. And when expansion is there, means work done by the system, and at that time the temperature of gas that goes on decreasing and internal energy also goes on decreasing. म्हणजे बघा, जेव्हा वर्क डन पॉझिटिव्ह असतं तेव्हा इंटरनल एनर्जी निगेटिव्ह असते, आणि जेव्हा वर्क डन निगेटिव्ह असतं तेव्हा इंटरनल एनर्जी पॉझिटिव्ह असते. म्हणजे ह्या दोघांच्या मध्ये 36चा आकडा असतो. वर्क डनचं तोंड इकडं तर इंटरनल एनर्जीचं तोंड इकडं. नेहमी लक्षात ठेवा, जेव्हा वर्क डन निगेटिव्ह इंटरनल एनर्जी पॉझिटिव्ह, आणि जेव्हा वर्क डन पॉझिटिव्ह तेव्हा इंटरनल एनर्जी निगेटिव्ह. या पद्धतीने इंटरनल एनर्जी आपल्याला एक्सप्रेस करता येते. आणि हे कसं फंक्शन आहे तर हे स्टेट फंक्शन आहे. इंटरनल एनर्जी हे कसं फंक्शन आहे, स्टेट फंक्शन आहे. अंडरस्टूड. नाव वी हॅव टू स्टडी अबाउट द स्टेट व्हेरिएबल्स. The state variables. State variable. Just now we studied that the thermodynamic state of system that can be expressed with the help of variables pressure, volume, temperature, mass, and that variable which defines or which with the help of which we can express the state of a system, that variables are called as state variable. They are also called as state parameters. And pressure, volume, temperature and mass, they are the state variables. Now, what is equation of state? Equation of state. Equation of state. A mathematical relation between the state variables, that is called as a equation of state. What is the mathematical relation in between these variables? The pressure, volume and temperature. P is small p here. Pressure, volume and temperature. Then PV, that is equal to nRT. Actually this is ideal gas equation, but this is in case of thermodynamics, this equation is called as equation of state. Here P is pressure, V is volume, N is number of mole, R is universal gas constant and its value is 8.314. This is the universal gas constant and T is temperature of the system. Okay. Now we have to study the next concept, that is PV diagram. That is a PV diagram. PV diagram. PV diagram, it is also called as PV graph. It is also called as indicator diagram. And we can describe the equation of state with the help of graph and diagram. That diagram is called as PV diagram, or it is also called as PV graph, or it is also called as indicator diagram. Now to draw this PV diagram, a variable on x-axis, that is always volume. Volume is always, this volume is always on x-axis, and pressure, that is always on y-axis. And this diagram which indicates the pressure and volume, that is nothing but the equation of state when plotted on a graph. That diagram is called as PV diagram, and this PV diagram is different for different processes. Later on we have to study the PV diagram. Understood? And this PV diagram, a graph which represent the equation of state, that is called as a PV diagram. Now, what is this PV diagram indicates? Suppose this is a diagram. Now, this is the pressure P1 and P2, volume V1 and V2. Now, this graph indicates that suppose arrow is in this manner, then this indicates that the point A having coordinates V1, P1 and B having coordinates V2, P2. Then, now in this case, this arrow indicates that a volume goes on increasing. Just now we studied that volume goes on increasing, expansion is there, and when expansion is there, at that time work done is always positive, and therefore area under the curve that gives you the work done. Because when we supply heat to the system and the position of the piston is in this manner, then this small work done dW, that is nothing but, if this displacement is small displacement is dx, at that time dW, that is equal to force into displacement, then this force, that is nothing but the pressure, that is equal to force per unit area, and therefore that is P into A into dx, and this A into dx, that is nothing but change in volume, and therefore this dW work done, that is small work done during that small displacement dx, and total work done when volume goes on changing from V1 to V2, and total work done, that is nothing but integration within the limit V1 to V2 P into delta V, and that is nothing but P into the V2 minus V1, that is the total work done. Understood? In this manner we can calculate work done, and when expansion is there, at that time the work done is positive, and work done, that is nothing but area under the curve. Now if we change only the direction of this arrow, understood? In this manner we can calculate small work done and total work done. Now, only if we change the direction of this arrow, only this direction is changed. V1 is initial volume, V2 is final volume, then P1 is initial pressure and P2 is final pressure. Okay. Now, then what happened? Volume goes on decreasing. Volume goes on decreasing, then compression is there. Work done is negative work done, and again area under the curve that gives you the work done. Means work done, that is equal to area under the curve. But in this case work done is positive work done. In this case work done is negative work done. Now third figure. In this case volume pressure remains constant, but volume goes on increasing. Volume goes on increasing but pressure remains constant. When volume goes on increasing, work done is positive work done. Understood? And area under the curve, pressure is here, volume is here, and area under the curve that gives you the positive work done. Work done, that is equal to area under the curve. And fourth case, if volume remains constant in this manner, pressure goes on decreasing but volume remains constant. When line is parallel to x-axis, pressure constant, and when line is parallel to y-axis, volume constant, and V is constant, at that time we know that V constant, then change in volume, that becomes 0, and dW, that is equal to P delta V, If dV that is equal to 0, work done is 0. In this manner, with the help of PV diagram, we can calculate the work done, and in this case volume goes on increasing, work done is positive. Volume goes on decreasing, work done is negative. Area under the curve that gives you total work done. In third case, pressure remains constant but volume goes on increasing, then also positive work done is there, and when volume remains constant, pressure goes on decreasing, then work done is 0. In this manner, we will study we studied the fourth cases about the work done, and this is the PV diagram. I hope all of you understood all this PV diagram very well, and in this manner the one shot lecture part first is over here. If you like this video, then like it, share with your friends, and also subscribe my channel, and also press the bell icon so that you will get notified about my new upcoming videos. Thank you very much.